in cubic system, where we are going to study first system, cubic system, and check what are the characteristics of crystals which are grouped in this cubic system. So any crystal, if it is having such 9 planes of symmetry, having 13 axes of symmetry, and having center of symmetry inside a crystal. So any crystal which shows such elements of symmetry, that is planes should be 9, axis should be 13, and center should be present in the crystal. Center of symmetry should be present in the crystal. That will be grouped under cubic system. How it is so, we shall see here. Suppose this is a cube, and the dotted line indicates the planes of symmetry. This is one vertical plane of symmetry, which divides crystal into two parts. One half part is towards us, and other part is other side. So this becomes plane of symmetry, possible plane of symmetry, because it divides this crystal into exactly two parts. One part other side, one part our side. Similarly, this direction, if you imagine that there is plane of symmetry, this becomes plane of symmetry because this divides again this cube into two parts, left hand side half part and right hand side half part, where one half part is exactly mirror image of other half part. So these two parts will be divided by this imaginary plane of symmetry. So this becomes plane of symmetry. Can you divide it horizontally? Yes. If you cut it horizontally, this plane will divide crystal into two parts, upper half and lower half, where upper half is exact mirror image of lower half. So this becomes plane of symmetry. Similarly, here diagonal planes are shown. One diagonal goes like this, dividing the crystal into two equal parts, this half part and other half part here. So this becomes diagonal plane of symmetry. Now other diagonal direction is like this, it is shown here. So again this divides crystal into two parts, this half part and this half part, which are exact mirror image of each other. So these top surfaces are considered for drawing the diagonals. Okay, if you consider side surface, here also you can have one diagonal plane of symmetry, which divides crystal into two equal parts, that is this half part and this half part. These two parts are equal, so this becomes plane of symmetry, possibly plane of symmetry. So after this side face diagonal, we'll go for this direction. It's shown in here. Same side face, but diagonal plane is trending differently in different direction. Again, it is dividing crystal into two parts. It is this half part and this half part. These two parts are equal. If you consider front face, is one diagonal here and another diagonal here, like this. So along this direction, the crystal cuts into two parts, this part and this part. Along this direction, crystal is cut into two parts, equal parts, this and this. So these are all possible planes of symmetry, out of which first three are called as axial. It is vertical, right to left, vertical front to back, and horizontal. These are three axial planes of symmetry, and rest of them are diagonal. You can see they are diagonal to the square-shaped faces. So 6 diagonal plus 3 axial, same as explained here. Planes, 9 planes. Okay. Out of which 9 we have 3 axial and 6 diagonal. Same are shown here, planes in 3 dimension. Is horizontal plane of symmetry, which is axial plane of symmetry, dividing upper and lower to half parts of the crystal. This is front to back going vertical plane of symmetry, which is again axial plane of symmetry, dividing crystal into left and right hand side parts. This is third vertical and axial plane of symmetry dividing crystal into two parts. One part is behind, one part is at the front side, and rest of them are diagonal planes of symmetry. All these first three are axial planes of symmetry, and rest of them are diagonal. You can see here, this plane is covering top surface. You see top shaped surface. This is one trend of diagonal. This one plane of symmetry. There is another plane here. Considering top surface, it is here. This is direction. Second diagonal plane of symmetry. If you consider side face here, this is one diagonal. Another diagonal with this trend is here. You see side face. This trend of diagonal plane of symmetry. This is this trend of diagonal plane of symmetry. This is front face diagonal. This is plane of symmetry. Second, with this direction, it is here. So 1, 2, 3. These are three axial planes of symmetry. The rest of the planes are diagonal planes of symmetry. 1, 2, 3, 4, 5, 6. So 6 diagonal plus 3 axial, that is 9 planes of symmetry. This is shown here, 9 planes of symmetry. All planes of symmetry are shown here. First vertical axial plane of symmetry, dividing crystal into two parts, that is this and this, or left hand side part and right hand side part, this blue color. This plane divides crystal into two parts. The first axial plane of symmetry, which is vertical. Second is here, right to left. This is also vertical, dividing crystal into two parts. Other side half part and our side half part. This. Third axial plane of symmetry is horizontal, here. Simple. So these are the three axial planes of symmetry. One vertical, perpendicular to that is second vertical, and horizontal is this. These are three axial planes of symmetry. Now the diagonal planes of symmetry. You can consider front face here, square shaped front face. This is first diagonal plane of symmetry. See how it runs. It goes like this. The first diagonal plane of symmetry, perpendicular to this is second diagonal plane of symmetry on the front face. So front face is covered for two diagonal planes of symmetry, this and this. Now go to the right hand side face. Here it is shown with the red lines, one diagonal, second diagonal. And now top surface, one diagonal, second diagonal. So when I say it is front diagonal, this, that means it covers other side surface also, this square shaped surface. It goes through back side surface diagonal also. That's why we are counting only front face two diagonals, that is this one and this one. Side face two diagonals, that is this one and this one, which covers left hand side face also. And top surface this diagonal and this diagonal, which covers bottom surface also. The diagonal are 1, 2, 3, 4, and top surface 5 and 6. 6 diagonal planes and 3 axial planes. So 6 plus 3 is equal to 9. Same is mentioned here. These slides are just for your better understanding. This two-dimensional approach. Planes are exhibited with dotted lines. Here planes are exhibited in three-dimensional model with a planar surface. Here one model shows all planes of symmetry. That is 9 planes of symmetry. Right? This is again cube. You can see vertical axis highlighted and one diagonal plane. is highlighted to understand what is vertical diagonal plane. There is another diagonal plane vertical like this, perpendicular to this. Okay. Similarly, there will be front diagonal plane and then side diagonal planes. So what you see is a vertical axis, and this axis going from the center of the square shaped face, the center, top face center to bottom face center. This is how the axis goes. The model shows vertical plane of symmetry, which is diagonal. Okay. However, the axial planes of symmetry, which are vertical, like this. This is axial, not diagonal. Axial plane 1, axial plane 2. We have seen in earlier model. This is that vertical plane of symmetry, which is axial. So it is not like this. Earlier you have seen diagonal plane of symmetry. Here it is like this, front to back. You can see it is passing through vertical axis. Earlier diagonal plane also was passing through vertical axis. This is vertical axis. And it is going front to back. This is axial plane of symmetry. Another axial plane of symmetry will be like this. Okay. If I turn the position for you, it will appear like this. See. If you consider this as a2 axis, so diagonal vertical axial plane will be right to left like this. This crystal model is belonging to the cubic system. You can see the front face of the cube is square shaped. Likewise, there are 6 square shaped faces. This is front face, this side face, this is back face, and this is left hand side face. Can you see? Yeah, these are 4 faces, and top face and bottom face. So this forms 6 face cube. This model shows 3 axial planes of symmetry. You can see here front axial plane of symmetry. This is the place of front to back axis, and this is the first axial plane of symmetry, which is going from front to back. You see here, like this, is going from front to back. It goes here like this. So this first axial plane of symmetry is here, which is vertical. You see, it's vertical. Vertical plane of symmetry. Perpendicular to that first vertical plane of symmetry, which is going front to back, we have second plane of symmetry going right to left. So this is second plane of symmetry, right to left. There is the axis place here at the center of this square shaped face. From here, the axis goes like this. This is A2 axis. From front to back is A1 axis. Top to bottom is A3 axis. So this was what first axial plane was. Second axial plane was here. This is perpendicular to the first. So front to back plane of symmetry divides crystal into 2 equal parts. Right hand side is equal to left hand side. 2 equal parts which are exact mirror image of each other. So this is second vertical plane of symmetry, which is axial. Is axis position. This also divides crystal into 2 parts, equal parts. This half is at the left hand side, this half at the right hand side. So these are 2 vertical axial planes of symmetry. You can see here third axial plane of symmetry is horizontal. You see here, this is horizontal plane of symmetry. This is also axial, perpendicular to this and this. So horizontal plane of symmetry is perpendicular to front to back vertical plane of symmetry and right to left plane of symmetry. Or
all three planes are perpendicular to each other, right? So this is about three axial planes of symmetry. Now other planes of symmetry are diagonal. How? Like this. One diagonal plane of symmetry which goes like this. The edge, it goes here. It goes here like this. Comes here like this. And here. So this is diagonal plane of symmetry. Very second diagonal plane of symmetry is like this. How it goes? It goes like this. Comes here. At this corner. Again here. So it goes like this. Here. 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 So this is front diagonal. This one. This was first. This was second. Okay. So once I say that this is diagonal, that means it is covering backside face also, isn't it? It is running like this. Like this, isn't it? That means it is here, coming from here. So it is covering backside face also. So when I say front diagonal 1, it is covering backside face also. The second front diagonal 2 diagonal covering front and back face. Now right hand and left hand side faces. This diagonal and this diagonal. So it becomes 4. First diagonal here, front face. 2, 3, and what remains is top. This is 5th diagonal. This is 6th diagonal. So I counted diagonal for you. This is first diagonal. This is second diagonal. Okay. Now third diagonal, fourth diagonal, fifth diagonal, and sixth diagonal. So there are 6 diagonal planes of symmetry, and here what you are seeing green colored are 3 axial planes of symmetry. So what you are seeing here, green planes of symmetry, are axial planes of symmetry. They are 3, and we have just counted the diagonal planes of symmetry. They are 6. So 6 plus 3 are 9. So there are total 9 planes of symmetry. Okay, so this model shows axial planes of symmetry, and rest of the 6 planes of symmetry you can imagine. This model shows all diagonal planes of symmetry here. You see here. This is first diagonal plane of symmetry. This is second diagonal plane of symmetry. That is this. So this front side and back side are covered. This. Now side. These 2 diagonal at the sides. So let's check how it appears. It appears like this. This is diagonal plane of symmetry. And perpendicular to this is this. This is another diagonal plane of symmetry. So these are 2 diagonal planes of symmetry covering side face and left hand side face. So what remains is top and bottom. Can you see here? This one diagonal plane of symmetry is another diagonal plane of symmetry. So check, this diagonal plane of symmetry runs like this. And this diagonal plane of symmetry runs like this. Can you see? So how many total diagonal planes of symmetry? 1, 2, 3, 4, and 5 and 6. These are 6 diagonal planes of symmetry. This model shows all planes of symmetry at place. You can see here.